Recording. Sweet. Please go to your attendance app so we can take attendance. We are CSCI 1. So just tell me that you're here. I'll leave this running until the end of class. And so today we're going to do programming. Yay. So we're going to learn a language called Scratch, and it lives on the internet actually. So if you just go to scratch.mit.edu, that will take you to the language where we will be working, the Scratch language. So everybody go here, scratch.mit.edu. Let me go back to the big screen so you can see it. That's where I want you to go right now, and we'll be playing there today. It's fun and graphical. I think you'll like it if you haven't seen it before. Let's see what else. So yeah, once you get there, you can just click Start Creating, and it'll open up a blank program for us. And I'll talk about what all this stuff means. You can close out of this. This is the Scratch cat. It's very, very exciting. So we'll come back to this. Maybe I can zoom in so you can see it slightly better. Is that as good as it's going to get for me, maybe? We'll see for now. All right, so now that actually got rid of everything, so I guess I need to keep it like that. My bad. So that is where we will be programming, and I definitely encourage you to play along with what I do in class right now. So try what I'm doing. It will be fun, and there should be plenty of time at the end to get started on your first programming assignment. Okay? So my goals for you, let's get started. Let's learn how to program. Maybe this is the first time we've ever done it. All right. So what I first want to talk about is just what is a program? Maybe we've never written one before. We're not really sure what that word even means. So I'd like to define it this way. A program is just a bunch of tiny little algorithms. And so I just threw off the definition onto another word. So what is an algorithm, then, you might ask? An algorithm is just a sequence of steps. Let's say that, all right? So it's really a recipe. So if you've ever made a recipe, then you have run a program before. That's all a program is. It's a sequence of steps in order to achieve some result that is desirable, right? So an algorithm is just a recipe, and so a program is made up of a bunch of little ones to make a bunch of little things, and that is your main course, right? That is a program in a nutshell. And so what I want you to think about right now is your first program. So pretend that I was an alien. I didn't really know what a peanut butter and jelly sandwich was. What would be the algorithm to make one? Tell me. Like, think in your mind right now. How would you make a peanut butter and jelly sandwich? How would you write down that recipe? Okay? So I'll give you like 15 seconds to think about it. And then I have a very interesting example with that. So what's your algorithm to make a PB&J? Say I've never heard of it before. So if you were like me when I first learned programming, you might say something like, all right, you want to make a peanut butter and jelly sandwich? Here's how I'll write it down. You're going to take some bread, you're going to get some peanut butter, you're going to get some jelly, just put them all together. You have a peanut butter and jelly sandwich, right? Easy enough. But if I were a computer and I were running your program, this is what I would do. This is what I would be thinking when I'm reading your recipe, right? So you said, all right, take some bread. So here's my bag of bread. I'll try and draw it all nice and 3D. So there's the bread, little slices inside. And all right, you said take some bread. There it is. Take some peanut butter, put it on the bread. All right, so here's a jar of peanut butter. I will put it right on top of the bread bag. That's correct, right? And then you said put some jelly on that too. So balanced ever so slightly on top of the peanut butter jar, I will put the jelly jar. Okay? And so that is peanut butter and jelly, right? Voila. I have, as a computer, run your program. I have made a peanut butter and jelly sandwich. That's exactly what it's supposed to be, right? And so obviously the answer is no, right? But the computer was so excited. It's like, shiny and new. That's exactly what you wanted, right? It followed your instructions. And what was the problem? The computer followed your instructions too exactly. that is the main difference between humans running programs, making recipes, and computers running programs. All right, so a computer is very smart, but it's also very dumb. We have to talk down to it at its level. Okay, we have to learn to think computationally. That's the goal for this class. When we're writing a program, we have to, and what does that mean? It just means talking in very little bite-sized chunks of instructions, using very small steps and being very specific when we're trying to say how to do something. So instead of my previous recipe, at the computer's level, we would have to say, get 2 slices of bread, put them down onto the table, get a knife, open up the peanut butter jar, put some peanut butter on the knife, use the knife to spread peanut butter on one of the slices of bread. Do you see where I'm going with that? That level of specificity is where you need to go when you're writing a program. Okay? That is the secret. So that's all it is. Okay? Any questions about that? We're going to learn to talk at the computer's level today. And we're going to learn it in a language called Scratch. So make sure you're here, scratch.mit.edu, and we will make some Scratch programs. All right? So here's my best drawing of what a Scratch program is going to look like. It's just a sequence of steps, but it's a graphical programming language, so we're going to drag out the steps and put them right on top of each other. It's like we're building like a Lego thing or something out of Legos. It's a program, all right? So here is what your program is eventually going to look like. It's a bunch of little blocks, we say, stacked on top of each other. If only I could draw properly. And so like here's the first thing you want to do in your program. It'll be a block. You drag it out. This is like operation 1. And then it's going to fit ever so nicely on top of the next thing that you want to do. Operation 2. It's just a bunch of blocks you drag out. And then if you want to do one last thing in your program, the third step, you'll put that below operation 2, and this will be operation 3. And so Scratch will run your program in this order, from top to bottom, as you're dragging these blocks out. It's first going to do this first operation, then this second operation, this third operation, whatever they may be. Okay? There's plenty of options. And so that's what's going to happen when we run the program. All of these blocks will be executed in order, we say. I'll just say execute in order. And the word execute, it's not like Scratch is killing your program or anything. It's another word for run. Okay. You'll hear me say that word a lot. Execute. It's another word for run, a synonym. So that's essentially what a program is going to look like for us today, at least. Okay. So let's go into Scratch and let me show you around. Okay. So there's a few windows. On the left, we have all the little blocks that we can drag out. Okay. The middle window is the program itself. Right now it's empty, it's blank. Okay? And I can zoom in, zoom out. I'll do that in a second. And then on the right, this third window is where the program will run. It will do things to this screen. So we can make animations, do cool stuff. And the default thing, the first start of the program, the one thing you have to work with, you can have more things, of course, is this guy called the Scratch Cat. Okay? So he's like the mascot of the Scratch language. And like he has his own Wikipedia page, at least on Scratch's Wikipedia. So there's lore about him. Super cute. He's called a sprite. So things that you can interact with in Scratch are called sprites, just little images that can move around and things like that. This one's name is the Scratch Cat. And so, yeah, you can read up about him if you'd like. Dun, dun, dun. So, that is him. And we can interact with him on our program. We can move him around. We can start him over here when our program runs. We can start him over here when our program runs. We can change properties about him. We can change his size down here. Instead of 100, I can make him size 200. Double the size. Giant Scratch Cat. And I can, of course, programmatically change this as the program runs, too, which is cool. I can change his direction, so he's, like, floating in space. I guess his default direction is 90, so he's facing to the right. I can move him around, and notice that his X and Y coordinates change. There's always a concept of where he is inside of the little program window. 0, 0 is somewhere over here, kind of smack in the middle. And notice that I put him over here, his x value gets small, and if it's up here higher, his y value is getting bigger, things like that. There's a coordinate system going on here, okay? And you can give him a name. Right now he's called Sprite 1. I could say Scratch Cat, whatever you want him to be called. And yeah, that's the idea. You can have multiple sprites down here. They live down here, and I can delete him if I wanted to. So that is the Scratch programming environment in a nutshell. We'll make it cooler soon. Are there any questions about it right now before I give you our first program? Doing all right? Okay. So it is customary when you're learning a brand new language to write a program called Hello World. It's like you've learned just enough to get the computer to talk back to you. Like it is now doing your bidding. It's become sentient. So I'm going to follow with that custom, and our first program is going to just output the words Hello World. All right, so let's find the block that does that in Scratch. We'll have the Scratch Cat talk to us. So you have all these things, these motion blocks, these looks blocks, and if you look hard enough, you'll notice that there is a say block. Say hello. Say hello for 2 seconds. So here's the one that we want. Say hello for 2 seconds, let's say. I'll zoom in on this program window. And here is a single block, and it will be our entire program. So I'll change what he wants to say. Hello world, and maybe he can say it for 3 seconds instead of 2. But this is one instruction, one operation in our program. And if I would like to run it, I can just click it. And once I click it, that operation is going to be executed. The program will run in the program window over there on the right. So if I click it, he says hello world in a little text bubble for 3 seconds. Exactly 3 seconds. So I'm clicking it, 3 seconds go by, and then he shuts up. Okay? That's our first program. Yay. Any questions about that? We did it. Isn't that fun? So that's one block, and let's get fancier now. Okay? That was kind of cheating to start a program just by clicking on the block. Usually, what you want to do is have an event, we say, to start the program. And the most common event is this little green flag up here. That's supposed to be the go button, right? So we'd like to be able to press this green button and have our entire program run from top to bottom. And so the way you do that is you have an event starting block down here, the yellow ones. So there's this one called when the green flag is clicked. Everything below it that's connected to it, because it's like Legos, will start running. Okay? So I'm going to connect these 2 blocks to each other. You see that? Do you also see how this event starting block doesn't have the right shape to accept anybody above it? It begins the program. It doesn't start it in the middle or anything. Only things can exist below it. You see that? So this is a more correct version of the Hello World program. And so now if I click this green flag, everybody who's connected to this when green flag clicked block will run. Okay? And there's just one thing still. And there he goes. Hello World for 3 seconds. That's our program. Click the green flag to rerun it. Okay? Are we doing okay for now? So yeah, we're going to use the green flag to start our programs from now on for a while. And notice that there's no room to have a block above that event starting block because they're supposed to start things. Yeah? And that's useful. That's pretty much all that we need to get started. The one last thing is just for us. I want to introduce you to this concept called comments, which are not blocks that run. I can just, let me say this. Let me right click on this Hello World block. I can add a comment to it, which is a little sticky note for myself. This is not code that's being run. I can just be like, I can explain what I was thinking at this moment in time, or I can explain what this is supposed to do if I'm going to give this program to someone else. This is a comment. It's not code. It's just for the programmer to look at. So if you write a very long program late at night and you go to bed, if you didn't write any comments, you'll probably forget what it was supposed to do in the morning when all your fancy code was doing. So write as many comments as you can. Okay? So in our world, they're just little sticky notes. Okay? That's everything I wanted to show you there. And now let me show you some cooler stuff. So here's my first in-depth example. Let's make a program where the scratch cat is like, I don't know, he's hungry. He's going to get a banana out of the fridge and walk away with it. Okay, so let me show you how to do animation and things like that. All right, so we need some sprites. We need a refrigerator. We need a lot of stuff. We need a banana. So let's bring them all into the program. So there's more sprites than exist here. I can choose a sprite, click it, and I can search for what I want. We need those bananas. He's going to be hungry. He's got to get them out of the fridge. And then I think there's a kitchen backdrop. So that over here on the right, choose a backdrop. In theory, there's like a kitchen somewhere. We'll find it. At least there used to be. House, maybe. Where are you? We'll use the hayfield in just a second. But am I really not finding it? Room, house. Yeah, I'm not seeing it. There's supposed to be one. At least there used to be. Kitchen. Fridge. Darn. House. Room. Oh well. Maybe it was a sprite. That's crazy. It used to be here, I promise. I'll have to find a new program now. Yeah, nobody finds it. There it is, refrigerator. Yay. Gosh, I was getting so confused. So I'm going to add that. And so now that's the background. And so here's the bananas in the fridge, and we're going to have the scratch cat walk to them, pick them up, and walk away with them. Okay, so he's going to move. So we're going to make him move. Let's see, how do I want to do this? I guess the first thing I can do is delete all this. We don't need this block anymore. We're going to do something different when the green flag is clicked. So let's work with the motion blocks. You see these? So right now, you can click a block to see what it's going to do. This move 10 steps block is nice because it's like, oh, move a little bit. If I click it, he moves 10 steps, 10 units in his little space in his current direction. And his direction is right now facing to the right. You see that? So he's going to go off the page right now if I keep him going that way. So that's probably not the one that I want. So let's delete that one. Bring him back this way. I would like the scratch cat to start here and then just kind of walk over to these bananas. And the way to do that is this go to coordinate block. Okay, you see that one? So I can say go to a certain coordinate and he will always move to there. So I would like him to go over here, which are the coordinates -158 and -99. Notice how no matter where he is, this like rechanges to his current position, so that's useful. So that'll always make him go to where he currently is. So if I move him back over here and I click this block, he goes straight there. Isn't that nice? But he kind of teleported there, so that wasn't good enough either. Let's find a different one. Let's have him glide there. That's more like walking, I would say. So start him back over there, glide 1 second to the fridge. So he's running over there. Okay? So start him over here, click the program, and he glides to the bananas. Isn't that nice? So that's the first start of the program. And then, so that's what I would like to do. I'd like to press the green flag. He goes to the fridge, gets the bananas, and walks away with them. When I re-click the green flag, it all starts over again. So right now, there's an issue. When I click the green flag, he's already where he's supposed to be. He's already where he's supposed to glide to. That's not useful. I think when the program starts, he needs to always start over here on the right. Does that make sense? So we better teleport him there before that gliding ever happens. So now we have 2 instructions in our program. Good for us. So now when I click the green flag, he goes to his starting position and then glides over to that new one. And it's always that. Always start here, move there. Start here, move there. Start here, move there. Does that make sense to us? This combination of operations? This is going to be key. All right, so now he's over here. We want the bananas to go after him. We want him to glide along with the bananas. Okay? That's what we would like to do. So how can we do that? Did I say anything useful? Yeah, let's kind of write this out. Let's talk about what things need to happen. So we got to start the bananas out in the fridge because they're also going to move. They need like a default location. That's important. What else? What else? And then while the scratch cat is moving, we don't want the bananas to move, right? We don't want those bananas to move at all because the scratch cat needs to take his time getting to them first. We can't tell the bananas to start moving before the scratch cat gets to the fridge. I'll show you the differences there. So that's going to be part of our algorithm. And then once the scratch cat gets to the fridge, then the bananas should move with him. And so we got to move that giant thing of bananas to the same place, the same coordinate that the scratch cat is moving to. It's going to walk away from the fridge, right? And then we want the animation to last just as long, so it looks like he's with the bananas at that point in time. Okay, so don't make him glide slower than the bananas were going. Okay, so there's a lot of things to keep in mind, but we're almost there. So we've got the scratch cat over to the fridge right now, and that's his program. Each sprite has their own program associated with them. Okay, so here I'm clicking on the scratch cat at the bottom here. This is his program. If I click on the bananas, I have an empty program. There's nothing happening to the bananas right now. So let's make something happen to them. Let's make a program happen. So when the green flag gets clicked for the bananas, we want them to go, want them to glide over here with the scratch cat as he's walking away, right? That's what we want them to do. But first, we need to wait for the scratch cat to get over there. So here's what we want to do with the bananas. We want them to wait for a second while the scratch cat is moving to the fridge. So there is a wait block. Dun, dun, dun. Do you see it? Is it control? Thank you. It's been a whole semester since I had to look for these. Sound, events, control. There it is, yeah. It's not obvious where it would be. So now, here's the idea. Both of these programs are going to run at the exact same time. That's the key. So while the scratch cat is walking to the fridge, the bananas better stay there. Wait for a second. Don't do anything yet, bananas. But after a second has passed, then we want the bananas to glide away with the scratch cat. And so now we'll do that, okay? So now the scratch cat is at the fridge after this block of code. Then we want him to glide back to over here. And so this will be glide 1 second to this position 154, -96. Okay? That's the key. So 3 things happening to the scratch cat's program. Start in his initial location and glide back that way. And then the bananas better wait for the scratch cat. He takes a second to get to the fridge. And then they better go to the same spot that the scratch cat is ending up, right? Because he's holding on to them. So they better glide 1 second to that position. Does that make sense to us? That's the idea. And so if I put the bananas back in the fridge, watch what's going to happen. We know what's going to happen to the scratch cat. He's going to go to his starting position, move over, come back. The bananas are going to wait a second and then glide to that same place the scratch cat's going. Did you catch that? Wasn't that cute? So there is one problem right now with the bananas. What would happen if I click the green flag right now? Can anybody tell me what's wrong? Yeah, I did not give them a starting position, so they'll just glide for a second to where they currently are, which is useless. So I better start them in the fridge, as usual. They need a starting position. Good. So at the very beginning, go to this nice default location for the bananas. Okay? So here's the scratch cat's program, the bananas program. We want them to align, so we got to wait for a second while the scratch cat gets to the fridge. So here's the bananas. Yay. And if I click it again, because of this first block, the bananas are going to start in a proper location. Okay? Any questions about this program? This is our first in-depth one. Is it making enough sense? So there's always a concept of ordering things on top of each other that happen first. And I think you can see that it's not obvious what needs to happen until you try. Okay. So if we're good with this program, I'd like to save it just so I can give it to you later. So let me just save this now. And then I'm going to make a brand new program. I'm going to go to File, New. Replace. Yes, go for it. So now I have a blank program again. And my fun example for us is Dun, dun, dun. Let's have the Scratch Cat getting abducted by aliens. Okay, so we got to do a few things. We need to set the scene, of course, and there was a hayfield. This is the perfect place to get abducted. And so what do we need to do? We need to have the Scratch Cat exist. We need to have an alien flying saucer exist. So let's bring that out into the scene. This UFO, alien saucer. It's somewhere. It could be a circle even. Let's see. A spaceship. Yeah, let's do the rocket ship. That'll work. So what we'd like to do is have this like come down, send out like a little tractor beam or something, and bring the Scratch Cat up and move along with him. Okay? That's the goal. So here's like the game plan. We need to set the scene. Okay? We need to put everything in their starting location. There's actually a word for that. It's called initialization. Okay? So we want to initialize all of our sprites to their starting locations. Okay? That is a key word that you'll hear me say a lot from now on. Okay? So we want to initialize all of our things. We give it a starting value. That's all it means. And so remember that we initialize the bananas location. We initialize the Scratch Cat's location in our fridge program. And here's what we want to do for this one. Here's my little algorithm. Here's my sequence of steps that we're going to convert to code that Scratch can understand and runs properly. All right? So we're going to make the UFO appear. The rocket ship appears. We're going to make it move closer to the ground because it's like coming down. It'll send out a little beam. We can make the beam right now. You can make your own sprite. You can paint one. So here's a little tractor beam that we could make. Boop. 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 And we can fill it with the paint bucket. With, yeah, purple's fine. And we can make it like, what's the right word? We can make it transparent, which is extra perfect for this. If you want to make a sprite transparent, that is, I think it's in looks. It would make sense for it to be in looks. And it is change something effect. It's not color effect. I think it's ghost effect by 50 or so. Let's make it 50% transparent. So there's our little beam that will come out of the rocket ship. Cool, huh? So let's call that a beam or something. I don't know. And so the idea is we want the UFO to appear, which means that initially it doesn't exist. It is not being displayed. So you can either show it or hide it down here. Do you see the little eye icons? So you can have a sprite that is not currently visible. You can hide it and show it. So that'll be useful. We'll make it appear. We'll make it come down. We'll make it send out its beam. We'll make the cat scroll upwards into the beam. Oh no. He'll go up into the beam. And then he'll disappear, because now he's inside the ship. And then the ship will fly away. Okay? And the beam goes away too. So that's kind of the game plan. Does that make enough sense to us? It's all of these things in order. That's the key. Okay, so if some things start out hidden, you can change whether something's hidden or not by looks, most likely. You have the show block and the hide block. Okay, if you want to show something, you click show, or you run the show block. If you want to hide something, you run the hide block. Okay, show, hide, show, hide. And this is for the Scratch Cat right now. You see him appearing and disappearing. Okay, so that is the game plan. Are we ready to try and implement it? Let's do it. Okay, so we want our program to start when the green flag gets clicked, of course. And so when the green flag gets clicked, we want to do some stuff for each of the sprites, for the beam, for the Scratch Cat, for the rocket ship. Bam. All like that. And I guess we always want the beam to be transparent, so we'll have that there. So what needs to happen? And I'll call this scratch cat as usual. What needs to happen? So at the very beginning, we would like the rocket ship to appear. So it needs to show itself. It'll start out hidden, but it needs to show itself. Okay? Dun, dun, dun. It needs to immediately show itself. This is the rocket ship's program. I have it selected down here. It needs to show itself. It needs to glide down to Earth. Right? So bam, it can move down a little bit. It can glide to there. So that will be in motion. Glide 1 second to that position that I just gave it. And if I want it to go here and start somewhere else, it better be initialized to somewhere different. Yes? So let's make sure it always starts out like up here or something. Okay? So the rocket ship starts out up here, shows itself, and then glides down. Oops, not to a random position. Oops, I dragged the wrong one out. Not to a random position, but to that exact position. Yeah. Start up there, glide down. Start up there, glide down. Okay, so that's what the rocket ship is doing so far. Does that make enough sense? And then it needs to send out its little beam at that point so that it can get the scratch cat up inside of it. So that means the beam should start out hidden. It should be initialized to be hidden and then appear after the rocket ship is in place. So the beam better, at the beginning of the program, hide itself. Please hide yourself. And then, make sure you're transparent, of course. Then it needs to appear only after the rocket ship is in the right spot. Right? So the beam needs to wait how long before it gets shown? How long does it take for the rocket ship to get there, to where it needs to be? What are our thoughts? These two blocks, the go to and the show, those are immediate. But we're waiting for the rocket ship to move down, and that's going to take a second. Yes? So this beam better wait 1 second before it shows itself. So in between that and the rest, it better wait a second. Just like that. Okay, so here's what's going on. Just like that. So this is the beams program. It starts out hidden. It makes sure it's transparent. It waits 1 second because it's waiting on the rocket ship to get in place, and it takes 1 second to get in place. And then it is finally showing itself because it's in the proper position. Any questions about what's going on here? Is that making enough sense for now? Just like that. And at that point, it can start bringing up the scratch cat. Maybe we want to start him down, I don't know, start down there or something. He can start there, and then he needs to get beamed up. So he needs to glide upwards. Okay, so the cat, we haven't given him a program yet, so he needs to make sure he's, we'll deal with that later. He needs to glide upward, right? So let's move him from where he is to like closer to the ship, so like right there maybe. That's a good spot for him. So glide 1 second to there. And then he's going to fly away, right? The beam and the cat will disappear after he's in the ship. So then it will hide himself, and the beam will also hide itself. And then the rocket ship will fly away. Okay? So let's see what we have so far. Are we doing the right thing? There are some issues with the scratch cat right now, actually. So if I click the green flag, the rocket ship's going to move down, starts in a starting position, moves downward, then the beam gets shown. But look what happens to the scratch cat. He immediately starts gliding even before the beam gets down. So we didn't wait long enough before we did that. And also, if I keep running the program, look at how the scratch cat never shows himself ever again. So he should be initialized to be shown, right? He should exist at the very beginning of the program. So we should show the scratch cat before we start anything, okay? Show him. But he's also not gliding anymore because we're not giving him an initial location. Okay, so we better do that too. Let's start him down here. Oops. Mr. Scratch Cat, please. Let's start him right there, let's say. And so that is go to whatever this 4 and negative 121 is at the very beginning. Okay, so that should work. Whee. Kind of. He's in the right spot, but he's not waiting for the rocket to get in place right now, is he? So it's all about timing. It's all about ordering. So it takes 1 second for the rocket to get in place, so that only after 1 second should the Scratch Cat start gliding upwards, right? So he better wait for a second. Wait for a second before you start gliding inside of the ship. You see how these all have to play together nicely? All these different programs. That's starting to look more like it. So this is just the Scratch Cat's program right now. He gets his default location. He makes sure he exists on the screen. He shows himself. He waits a second because that's how long the rocket ship takes to glide down. And then he starts gliding inside of it. He goes up for 1 second and then he gets hidden because now he's inside the ship, right? So that's actually exactly what we want to do for the Scratch Cat. The only extra stuff is we want the beam to go away at this point, and then we want the rocket ship to fly away. Okay? So how long should we show the beam for? Is my question to you. What do you think? Good. Yeah, we got to wait for the Scratch Cat. So the beam is shown, and then we have to wait how long for the Scratch Cat to go up. That 1 second, that was his animation time. Good. So I think just 1 is fine. So it's another wait for the beam. Show yourself for 1 second. Okay? And after that 1 second, the Scratch Cat's animation is completed, and we can hide the beam. Looks. Hide. Does that make sense to us? And now I don't actually have to have the hide at the start because it'll always end with hidden. But I'll just keep it as it is. Not a big deal. That is key. We have made all of our different sprites play nicely with one another. So there's the Scratch Cat. The beam waits 1 second, stays shown for 1 second, waits, and then hides itself. All of these things are happening in order. You see that? And so the very last thing that needs to be done is the rocket ship needs to fly away. Fly up into the screen. And that will be right down here. So the rocket ship is in place. He needs to wait for the Scratch Cat to get beamed up, right? And for him to disappear before he flies away. Okay, so this rocket ship better wait how long? I think it's 1 second, right? That's how long it takes for the Scratch Cat to get up into position and disappear. So wait 1 second, Mr. Rocket Ship. And then we'll comment all of these in just a second. Because this is getting to be a lot of waits. What are we waiting for might be your question. So after that, after 1 second, please fly up here, rocket ship. And maybe the Scratch Cat's super heavy, so he'll take 2 seconds to glide away. Okay? How about that? So this is the rocket ship's program. Go to a starting location, show yourself. I guess he's never hidden. We don't have to show the rocket ship. We'll just keep him there. Glide 1 second into location, send out the beam, wait for the Scratch Cat. That's 1 second, and then take 2 seconds to glide back up to the top. Okay? So that is a super cool program, I hope. But it might not be too obvious what we're doing. Like, I had reasons for dragging all of these blocks out, but do we remember them all? This is the time to add comments. Okay, actually, we should have been adding comments as we went. So what do all these weights mean? That's probably a good thing to comment. So this is the beams program. We have to wait for the rocket to get into place. That can be our first comment there. That's why we're waiting for a second, because it takes a second for the rocket ship to come down. And then, why are we waiting for this 1 second? That's how long it takes for the Scratch Cat to get beamed up. Okay, and so do you see how this is super useful? If you come and look at this program tomorrow, these comments will save your life. If you wanted to change it a little bit, it'll make a lot of sense when you read these little sticky notes that you left for yourself. Okay? Same with this. Why do we wait a second before we glide? This is the amount of time that it takes for the rocket ship to come down. Wait for the rocket ship to glide down and for the beam to show itself. Okay, because that's what's going to happen after that 1 second. And then the scratch cat glides into the rocket ship and goes away. And why were we waiting for this 1 second for the rocket ship? It was the rocket ship's program now that I'm looking at. We waited 1 second here because this is how long it took to beam up the scratch cat. It gets beamed up, and for the beam plus the scratch cat to disappear, to hide. Okay? And of course you can add as many comments as you like, but all of these programs now, they make a bit more sense with them. And I hope that you can, with enough practice, look at each of these 3 programs for each of these sprites and understand the point of all of them, why we made those choices, why they all correspond and why they all come together to make a nice, cool looking program. Okay? So yeah, in a nutshell, that is my example program. Are there any questions about this one? This is, of course, the most complicated one that we've made today. Are we all doing okay with it? Because what I'd like to do for the rest of the time, before I show you your first programming assignment and give you time to start it, is I'd like to give you a chance to change this a little bit, okay? I'd like you to take this program that I've made for you. I'm going to save it. And I guess the easiest way for me to give it to you is to like drag it into Discord. So if you'd like to log into Discord, go for it. Otherwise, maybe you already made the program with me. Either way, let me give you this, at least what I have right now. Dun, dun, dun. I assume this went to my downloads folder, so let's go there. Boop. And I'll give this file to you. And if you'd like to open it in Scratch, you just go to File, Load from your computer. So I'll go to CSCI 1, and I'll drag this file to you. So this is my program that I wrote, if you'd like to look at it, if you didn't already make it yourself, or you followed me. So now you have it, and I want to give you like, I don't know, 5-7 minutes, as long as you need. I would like you to work on that example. So take what I did, or what you did as you followed along with me, but change it up a little bit. Make it so that the scratch cat gets away safely. Have him like do something cool. Have him yell at the aliens as he runs away to the side or something. You can have him say things. You can have him move away. Change up the program a little bit, and that will help prove to yourself that you understood what's going on. Okay? And feel free to work with each other, like introduce yourself to the people sitting next to you, get help as you need it. But I want you to try and recreate this program and change it ever so slightly, maybe make it so the scratch cat gets away or something else of your choosing. And I've just given you my code. So I'll give you like, I don't know, 6 minutes to think about all this, and then I'll release your first programming assignment. Okay? Get some experience with Scratch. And of course, you can ask me questions as you're working if there's something you don't know how to do and you're wondering about it. think there's an explosion sprite as well if you'd like to have the Scratch Cat blow up the alien rocket ship. That's always a possibility. Oh, yeah. So right now you have it to start with. That's totally fine. But right now your program is that's the key feature right now is each of these three blocks they run one after another with no delay. So your program's so fast that you only see the show. It's hiding and showing itself in a blink of an eye before you get it. Yeah. So if you want it to stay hidden for a while, you want to wait for it. Oh, has everybody had a chance to sign in for attendance? Can I stop that now? Please do that. So I'm going to make sure to do one thing after I do that. It's www.lautensclass.com. It is this right here, which is probably not visible from where you are sitting. Okay. So yeah, please mark yourself here. So feel free to keep playing, but that was the end of my timer. So I just want to remember to share with you our first programming assignment. That's the end, and then you can have time to work on that or play around with Scratch, whatever you feel like doing. Okay, so let me talk about your first programming assignment. Yay! So this one will be due week 3, I'll give you 2 weeks to do it just because I would have given you time on Monday if we had class on Monday, so I'll just give you an extra week. Who cares? All right, so that should be available on Canvas now for you to read. And here is the deal. I first should also say, in case I didn't say this loud enough last time, these first few programming assignments have 2 options. One for if you've never programmed before, and one for if you have taken a CSCI class already. The other option would be for you, okay? So pick the one that applies to you and submit. Okay, so if you have never programmed before, you'll do this first thing. It's called Hour of Code, okay? So you'll go to hourofcode.com and pick one of these fun activities, and it's a Scratch-like language for each of these, if not exactly the same as Scratch, but you can make Flappy Bird, you can do stuff with Minecraft, make fun little games, animations, things like that. So pick whatever sounds cool to you and complete it. You'll get some kind of either a completion message or like a certificate. Just take a screenshot of that, and that will be what you turn in for this assignment. Okay, just show me that you've completed one of these Hour of Code activities. Okay, so that will be your submission there. And if you have programmed before, I'm going to force you to learn a new language that you might never use ever again. But it will expand your mind, and it's really cool, I promise. Okay, so I would like you to read the first 2 sections of the first chapter of this book called How to Design Programs. So you click on that, and I guess you just click on the book to start reading it. And then here on the left is the table of contents. Here is the first, this is the first part of the book. Here's the first chapter of the book. Okay, so here's the chapter on arithmetic. It's going to teach you a language called Racket. Okay, there's nothing but parentheses in the Racket language, so that'll be interesting to learn about. So you'll read 1.1 and 1.2, and then you will do these assignments from the book. Okay, you'll do exercise 2. Okay, so install Racket. There is you'll just search for it. Search for the Racket programming language, I guess, and you'll install it. Okay, there's a program called Dr. Racket that I recommend. So you'll download that for Windows, and there will be a program called Dr. Racket where you can edit Racket files. Okay, so just ask me if you're having any trouble with that. But I want you to do exercise 2, please, from that book. And so that is going to be 1.2, I guess. Oh, no. There it is. Exercise 2. You'll add some definitions, and I want you to use these 2 variables that you've made to make hello_world. Okay, something very simple, but getting you used to this new kind of language. So this is for if you've programmed before. This is what I'd like you to do. Okay, and if this doesn't seem cool enough to you, and you have your own idea of what you'd like to do when you've programmed before, then just talk to me, and we'll come up with something that meets both of our goals. So something that makes it so that you learn something new. That's my goal for you, and that doesn't bore you. That could be your goal. Okay, so that is those are your 2 options. All right, any questions about this assignment? Well, let me do week 3. When have I said? January 27th. So that's going to be the Thursday. So 2 weeks and a day from now. Okay, and so upload a screenshot of you completing that Hour of Code activity, or upload a screenshot of the results of your exercise 2 assignment, showing that you got the right answer. Okay, so that is officially all that I have for you. So feel free to get started on that now, or play around with Scratch. The possibilities are endless, and I'll be here to answer your questions until the end of class. Okay.